Hello, these are your notes for section 8.1, and this is on composition of functions. This is one of my favorite sections just because it has so many applications, and you don't know that you're doing this, but you really are. There's almost always an ACT type question on composition of functions, so I really hope you enjoy this. Here's a journal choice. You should probably do one this chapter at least, and you can ask me for more details of that in class. Alright, here's an activity I want you to take a look at. I think it's funny. Lehman's car dealership, like lemons, get it? Funny, okay? Offers two incentives to car buyers. They give a 12% discount off the $33,000 sticker price of a new car, as well as a $2,000 rebate for the end of your clearance. If you were given a choice, which incentive would you take first? This is common sense to a lot of my students, especially in Honors Algebra 2, because you see numbers so well. But let's figure out which way is best. So let's do the 12% first. If we do 12% first, we're going to take, I guess you could do 0.88 times 33,000, because you're actually paying, where's my pen? You're actually paying 88% of the full price. And I get 29,040. Some of my students like to take 0.12 times 33,000, and that would give you the 12% off, and then take 33,000 minus that price. That would also work. 3960. Either way, you're getting oh, I did that backwards. 3960. Either way, you're going to get $29,040. That's for the 12%. Now we take the $2,000 rebate, and we get $27,040. That's the rebate. If we do rebate first, we are going to have a $31,000 sticker price, pretty much. We can then do the 0.88 times the 31,000, or you could subtract like we did before. And then we get 27,280. Okay? So, which method should we do? Well, I would choose the 12% first. And how much is it going to save us? Well, it's going to save us $240. Order definitely makes a difference in this situation. Let's talk about why you should choose a percentage first. Well, 12% off a bigger number is going to give you more money you're saving. This is 12% off of a smaller number, so it's not as much money that you're saving. Okay, this is composition of functions. Composition of functions is doing one thing followed by another, okay? This notation you may have seen in geometry before. Suppose transformation T1 maps G onto G prime, and transformation T2 maps figure G onto double prime. Then if you go straight from G to G double prime, first you do the first transformation, then you do the second one. So we do T2, and it's a little open circle. I don't know if you can tell. That's the composition symbol. And it's T2 following T1. So that the thing that's listed second is actually what happens first. T2, because the little circle means following. Okay? So you go here to what happens first, and then what's listed first is actually what happens second. So T2 following T1. That is symbols. So let's talk about that situation and activity. Suppose the rebate was $1,500 and the discount was 22%. So R of X is X minus $1,500. That's a way of saying the rebate function. Take the price, subtract $1,500. The discount, percent discount function would be 0.78x for the reason I told you before, or you could have taken x minus 0.22x, which is the exact same thing. They want to write an equation for the whole entire price, okay? And it looks like this, R of D of X. So we're going to do the discount first, because that's in the innermost parentheses, and then the rebate. This is read R of D of X, and I wrote it down right here. You could also write R, open circle D, R following D. So D happens first. I will almost always write it with the double parentheses, because I see the innermost parentheses. Okay, so when we do this, we write it just like this. They want one equation so that you don't have to do the problem twice. Well, P of X is going to be R of D of X. Well, what was D of X? D of X was 0.78. Okay, so now all I did was substitute there. I have the price is R of 0.78x. Now if you remember, this is telling me to go to function R, and plug in 0.78x for x. That's what I'm going to plug in. So I'm going to go back to function r, which is right here, and wherever I see this x, I'm going to plug 0.78x instead. So now, p of x equals, go to function r, here it is. There's my x, so I'm going to put 0.78x instead, because that's what the directions tell me to do, subtract $1,500. So if I want one equation so that I don't have to do it twice, I could just do this, 0.78 times the price, subtract $1,500. Okay, what would the equation look like if I did d of r of x? Well, this is going to be q of x. First, we're going to take the rebate this time. So the rebate was x minus 1,500. Think about what this is telling me. This is telling me to go to function d. And wherever I see an x, I'm now going to plug x minus 1,500 in instead. So go to function d, which is right here, 0.78 times x. But I'm not going to use the x. I'm plugging in x minus 1,500. So my new formula is going to be 0.78x, 0.78 times 1,500, minus 1170. Okay, that's the q of x function. Now, you can see that these two are different, and you can also see what the difference of the value will end up being. Okay, 1,500 minus 1170, $330 difference. Is it true for all x that this one will be better than q of x? Well, what you can do is graph both of these, and I don't. There it is. 1,500 and 1170. Gotta remember that. 1,500, 1170. Okay, I got this loaded. I'm going to go ahead and type in 0.78 minus 1,500. That's one of them. And tab 0.78 minus, what was the other one? 1170. Is that right? Okay, and I can tell absolutely nothing from, I want to make sure this is right. Great. From looking at this, I need to change my zoom. So I'm going to go here to menu. Let's take our window. We only want quadrant 1, first of all, but still this is not big enough. So let's do menu, window zoom, zoom out. Over here. Where's my graph? Oh, minus 1170. What am I doing? There they are. Now I gotta zoom in. Okay. Is it true that the second function will always be a worse deal than this? Yes, the answer is yes. These are parallel lines. So the price of this one is always going to be greater than the price of this one. You didn't really need to graph it to look at it, but it is true that always, 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 this p of x is going to be underneath the graph of q of x. Okay, so what is composition of functions? You can think of it like a machine. When you have a function f, it's a rule. So let's say the rule is x squared minus 64, okay? So that means when I plug something in the function f here, it's going to spit out x squared minus 64. So if I plug in 2, it's going to shoot out 4 minus 64 or negative 60. Okay, that's a function. Now, here's another function. If I plug in 2 to function s, it's going to shoot out 1 over 4. A composition of functions when you put the two machines and you build them together. Okay, so here they're plugging in 7. 749 minus 64, and you get negative 15. It then takes that output and plugs it into the new function, and it gets 1 over 125. Okay, and this would be s of f of x, because f is happening first, so it goes on the innermost parentheses, or you can write s circle f. Okay, happens first, follows, and then that one. Okay, formal definition, you need to think about order of operations. The innermost parenthesis is where we start, so you're going to start right inside here at the f of x. The domain is tricky on some of these. Example 3, we'll talk about this in a second. Basically, you need to see what limits f, can I plug everything into the last thing, and then you have to look at them individually. Okay, so here's some ways to write it. This is mapping notation, G circle F colon X. But like I said, I don't really care. Just to be familiar, you'll see this. I almost always prefer to write it this way. But you need to be familiar and able to read these. Okay, so here's some functions. Find an expression for f of g of x. Yeah, right away I'm just going to rewrite it. I'm going to plug in g of x first. So now I have f of, what is g of x? That's 2x squared. Now this is telling me to go to function f and plug in 2x squared for x. So here's function f. Wherever I see an x, I'm going to plug 2x squared instead. There it is. So f of g of x is going to be 2x squared plus 5. All right, how about g of f of x? Well, g of f of x is going to be g of x plus 5. That's what f of x is. This is telling me to go to function g. Here it is. And wherever I see an x, put x plus 5 instead. Be careful here, because this x plus 5 is going to be taken to the second power, the whole quantity. So I'm going to have 2 times x plus 5 quantity squared. If I was going to expand this, I would have 2 times x squared plus 10x plus 25. I just expanded that binomial. I hope you remember how to do that. And that ends up with 2x squared plus 20x plus 50. Okay? Remember when I do the x plus 5, when you expand that binomial, you double distribute here. That's how I got there. I did it in my head with a shortcut method. Okay? So when you do these, it might help you to write it this way. Plug in the function that they're asking you to use first, and then take that function and plug it into the other one. Alright, so let x be a real number. T of x is 1 over x, and g is x squared minus 100. What is the domain of t of g of x? So here's what happens. T of g of x. So that's t of x squared minus 100. Okay, what can I plug into x squared minus 100? I can plug in anything I want, right? Anything in the world I can plug into this guy. There's no restrictions here. What can I plug into t? Well, this downstairs cannot equal 0. So I can't plug 0 into t. So think about that machine. G happens first, and you get something. Then t happens, and you get your final answer. Okay? We can put whatever numbers we want into here, we said, right? But the problem is, I can't put 0 in. I can't put 0 in here because that will break this function t. So, when I look at that, well, what determines what comes out of this box? G actually does determine that. So what happens is, when I plug something in, x squared minus 100 cannot equal 0. Because when it equals 0, that is when my function t will break. So I actually have to solve that. So x squared equals 100. I add 100 to both sides. What numbers will make that true? Well, x, square root both sides. There should be 2 answers. X cannot equal 10 or negative 10. Because when I plug in 10 or negative 10, I will get 0 out, and then I can't plug that into function t. Okay? So how about if I did g of t of x? This one's a little easier. Is there anything I cannot plug into 1 over x? Yeah, I can't plug 0 in, right? So can't plug 0 in here, so x cannot equal 0. But after that, I can plug whatever I want into function g, so there's no restrictions. So this one, there's only one restriction, x cannot equal 0. Here there were 2. A little tricky, but we'll be able to talk about it in class when you guys have questions. Okay, that was my composition, and we will do more problems in class tomorrow. Thank you.